Hi, I'm Doug Sparks, the CTO of Hanking Electronics, where we're proud to be the first company to make a 200 millimeter pure MEMS wafer fab. I've been with Hanking for 10 years, and I'm going to share with you some of my insight and observations on the last decade of semiconductor and MEMS supply chain improvements in China. Now, big first question for this is what's driving this big improvement in infrastructures for semiconductors in China? We've seen a steady growth in the consumption of semiconductors in China over 15 years. Uh, until about 2020, the percentage of integrated circuits, MEMS devices that were actually fabricated in China, wafers, for example, or chips, was about 17% or less. The Chinese government has seen this and wants to increase the local content for ICs and wafers from anywhere from 40 to 70% of internally manufactured wafers and ICs. So this is a big goal, an aggressive goal, and it's caused the country to invest a lot into this area. If you step back and look at worldwide IC market share, this includes headquarters, final products, as well as wafer fabs and components and OSATs. You see that the US and South Korea are by far the leaders. China has about 5% of this market share. So you can see that there's a lot of room to grow, and it's going to take a lot of work to get there. Now, a semiconductor ecosystem is complex, and it's made up of a lot of different parts. There's wafers, chemicals, equipment, photomasks, there's people, there's education and IP, and of course there's funding. So you need a lot of money to expand this ecosystem and a lot of time. Now, Yole Development did this snapshot of the China's semiconductor supply chain a few years ago, but it does show uh, the large number of fabless companies that are already existing in China, as well as wafer fabs. And I added a few MEMS fabs down there, Hanking and Silex, which are now wafer foundries making 200 millimeter wafers. It also kind of shows the equipment suppliers that feed these foundries. And this has grown up spectacularly over 10 years. Now, one of the things that's missing in the equipment supply chain is sub 14 nanometer lithography tools. So that's something that's missing, and I kind of highlighted that on this. Another big change that's happened since this chart was made is the number one OEM in China is no longer Huawei, but now it's Xiaomi. They're number one in China for smartphones, and they're number two in the world. So they're using a lot of MEMS components, a lot of semiconductor components, and that's a shift that we've seen in the last few years. Now, I like to put together a SWOT for any new subject or new project, and this is my SWOT that I've assembled for China's semiconductor and MEMS manufacturing industry. There are strengths, weaknesses, opportunities, and threats. The strengths are the large amount of funding that's gone on in the past decade, the large number of wafer fabs that exist, the labor pool, lots of engineers, and lots of patent activities. Weaknesses include uh, a lack of high volume MEMS personnel. This is ramping up. There's competition for talent between CMOS power IC fabs and MEMS fabs. Opportunities, of course, we just talked about that. There's a huge market for ICs, for MEMS devices, wafers, and final products. As I mentioned, there's lots of government funding. The threats are the labor rates. Real estate prices are high, particularly in Shenzhen and Shanghai. There's been trade issues. There's been a stoppage in a lot of merger and acquisition activities in the last few years. And of course, COVID is affecting international travel and supply chain. This chart kind of shows you how many wafer fabs there are in China and where they're located. You see a lot in the Shanghai area, probably more than 40% are in that area if you include Suzhou and Wuxi. I circled the area where there are MEMS fabs, Shenyang, where our live conference is being held, as well as Beijing, and again in the Shanghai area. Now, there have been several paths to growth for the semiconductor industry in China. A lot of this started off for manufacturing with international uh, IDMs and foundries building fabs in China, starting back in the 90s. Of course, there's been organic Chinese startup companies in fabs like SMIC, H.H. Grace, Hanking. There have been startups of tool manufacturers, wafer manufacturers, Shenyang Silicon, for example. As I already mentioned, there's been a lot of government funding. We've had the big funds, and those are often tied to local grants uh, from cities and provinces. We had a big spurt of M&A activity in 2014 and 2016. And we had the Star Stock Exchange start up in 2019. International wafer fabs. Let's look at that kind of historically. Back in the 1990s, Motorola uh, put one of the first fabs in Tianjin. We saw Intel put a memory fab in Dalian. This was just recently acquired by SK Hynix. TSMC, Samsung, and others have also put their own wafer fabs. This brings in a lot of talent, proven processes, tool sets, management, and lots of money. And it's done to gain market access. It may not be leading edge technology, but it certainly generates the infrastructure that's needed to support this big ecosystem. Most of the fabs are 28 nanometers and above. And some of them, after about a decade of use, are sold to Chinese companies. Now, I'm sure we've all heard about China's Big Fund. It's their government way to fund expansion of the industry. It started in 2014. Phase one was about 22 billion US dollars. It was supported by the finance ministry and several other Beijing banks and other industries. And we see phase two starting this year. So far, the bulk of it, 78%, has been allocated towards wafer fabs, towards fabs equipment. We've seen a 12-inch fab get a lot of support, and we've seen AMEC get support for their plasma etch technology. In 2014 through 2016, we saw a lot of related mergers and acquisitions. Hanking Electronics, I was involved with this with Hanking. We acquired the Maxim integrated inertial MEMS business. SMIC acquired Foundry that year. We saw Silex be acquired in 2015. Achmetic, a long-time wafer supplier out of Finland, was acquired in 2015, as was Omnivision, which was one of the world's leading suppliers of CMOS imaging sensors and wafers. So those were just some of the examples that happened. This has virtually stopped. M&A has virtually stopped, and in 2020 we saw a 9-year low in M&A activity, across the board, and specifically in semiconductors. A new development we've seen in the last few years to raise funds for tech companies is the STAR market. This was launched in Shanghai in 2019. It's kind of a NASDAQ-like stock market geared towards tech companies, particularly semiconductor companies and fab-related tool companies and technology companies. There's been over 175 companies listed so far in just 2 years. So this is going to be a key driving force in getting IPOs and monies in these tech companies. And some of the local companies, at this conference, think of King Semi. They went public on this. Of course, everyone's heard that SMIC went public. It was the biggest IPO on the STAR market to date. Education is key. It's a key part of the ecosystem. China graduates about 4 times more engineers than the U.S. So you see they're cranking out engineers. A lot of grad programs have been started across the country related to sensors and MEMS. You see a huge number of patents being filed in this area as well. And last year in Nanjing, they opened a chip school focused specifically on training technicians and engineers to work in wafer fabs, to try to meet the huge need to fill these fabs that's been built across the country. Now, if you look at China as well as anywhere in Asia, you'll see just a huge amount of OSATs. Packaging capability is there. China has a number of these facilities in Shanghai, Suzhou, Hangzhou, Beijing. If you need an IC or a sensor package, even these customized like infrared sensor packaging or automotive pressure sensor package, accelerometers, it can be done in China. So that part of the ecosystem is certainly in place. Wafer suppliers, again, those have been developed over the last 10 years, not just silicon wafers, but epitaxial wafers, silicon on insulator or SOI wafers, for example, Shenyang silicon and Sigmui. You see the ability to do CMP and grinding, and even glass wafers for photonic bonding. 3/5 compound semiconductors are available. Buried cavity SOIs, so you can get pattern buried cavity SOIs for making MEMS devices. So again, that's another part of the infrastructure. You can get anywhere from 100 to 300 millimeter wafers in China, made locally now. Fab equipment is another area that's seen a lot of attention, a lot of funding. As I mentioned, the big fund is putting some money in AMEC, which is kind of I guess, competing with Lam, Orbitech, TEL, some of those other plasma etch providers. Some of the big companies like Applied Materials Applied has a huge facility in Xi'an, China to support 200 millimeter tools and training. That's just an example of how international companies support the ecosystem. But there are, internal companies, Shanghai Micro making steppers, King Semi making tracks, Piotech making PECVD tools. So there's a wide breadth of semiconductor tools being made in country, and I see this trend is marching forward, and the quality of the tools improving over the years. Now, I mentioned photolithography is a weak link in the semiconductor ecospace for China. Right now, there are primarily 28 nanometer and larger geometry lithography tools in the fabs there. If you look at this chart that's shown here, look at where the EUV tools are. So that's for 5 nanometer, 7 nanometer lithography tools. Those are almost exclusively at TSMC, Samsung, and Intel. SMIC doesn't have these tools yet. Now, there is talk that by 2022, 14 nanometer tool capacity will be existing in large volume in China. So that'll be the next step. And of course, Shanghai Micro is seeing the support there to develop its own tools as well. Now, how do you fully expand your semiconductor ecosystem if you don't have the leading edge lithography tools? And one way is to take the more than more approach. So we're going to go beyond Moore's law. We're going to start using methods besides lithography shrink, methods to increase capabilities, wafer bonding, chip scale stacking and packaging. Beyond 8-inch and 12-inch wafers, you go into things like roll-to-roll, panel printing, 3D printing, of course, compound semiconductors, and then niches like MEMS, power, analog ICs. And to take on other markets, flex technology, solar. Those are all ways that the resiliency of the supply chain can be improved without having this advanced edge lithography tools. And this approach has been taken across China. There are so many niches and so many applications that don't need, 5 nanometer lithography. There's plenty of work to be done without that. I'd like to now kind of focus on the progression of the MEMS industry in China. That's my specialty. I think I see MEMS wafer fab progression in China as being broken up into 4 stages. The first stage was your university and government institute labs. Those were 4-inch and 6-inch wafers. Although right now there are some universities that do 8-inch wafers. Now, stage 2 I saw as something that happened around 2000, where OSATs, packaging firms and companies in China, were importing wafers, MEMS wafers and chips, ICs, etc., doing the package and testing. Um, for example, in Shenzhen to make microphones. That went on for about 10 years. And in that time period, companies like SMIC and other older CMOS fabs started developing surface micromachining technology for MEMS using sacrificial etching. So up till until about 2015, if you wanted to have MEMS wafers in China, you could get 6-inch and 8-inch surface micromachine CMOS type wafers. And now we're in stage 4, where we actually have high volume, pure 8-inch MEMS fabs there, combined with the surface CMOS micromachining. I will add, though, that as of 2020, most of the MEMS wafers and chips are still being imported into China. So the facilities are there, but we still haven't made the full switch over to manufacturing the majority of the MEMS chips in China. If you look at all the different combinations and how the supply chain works in China, there's all various combinations of manufacturing. You have fabless companies. You have companies with their own MEMS fabs. And then they'll use foundries, MEMS foundries, CMOS foundries, packaging services. So basically any combination you can think of is already there. An example of like our stage 3 fab processes would be the CMOS sacrificial wafer process. And this was pioneered by Motorola and Analog Devices back in the 1990s and 80s even in the US. MEMSIC is a good example of a Chinese company using this technology to make flow sensors and accelerometers. So they'll actually get a CMOS wafer and then undercut the elements to form the freestanding thermal membranes or thermal elements. And this is a way to not only go into manufacturing for 6 and 8-inch, but I see it as a path to go to 12-inch. It could be the first path to go to 12-inch MEMS wafers. We already have heard of a company called Butterfly Networks that's making capacitive devices on 12-inch wafers. So it's possible in the future China will take this approach for 12-inch MEMS. An example of a stage 4 company is Hanking Electronics, and that's where in this conference there's been a tour, and I think all the participants that came to the China live version got to see this on Sunday. It's an 8-inch dedicated MEMS fab located in Shenyang, northeastern China. And I think it's pretty safe to say that, since MEMS devices don't need sub 50 nanometer lithography, that all the technology gaps in the MEMS supply chain have been closed in China. So that's progress. Of course, you can't talk about the semiconductor industry without talking about the impact of COVID. And I know we have a talk specifically on that. Leonardo Sala is going to be talking about that. But I'll just give a couple of remarks. We saw COVID hit in 2020. There were lockdowns in cities across China. It was a big supply shock for a couple of months. Travel bans were put in place. Logistic troubles were seen. Fab tool startups were delayed. And there are still travel issues. It's still hard because of the quarantines to get international teams and expats into China to help out with wafer fab problems. There was a supply chain shock. Of course, the economy shut down in Q1 and Q2 of last year. And then we're still reacting to this supply chain shock, this shutdown as we start up, and we're seeing these shortages, and everyone hears about IC chip shortages and rebalancing the supply chain. China's taken a really interesting approach. They've gotten government support in there. It's very, it's a very complex uh, system of controls and assistance, trying to break down paperwork and logistic barriers and freeing up some investment where there are supply chain issues. So it's really been very interesting to see how China has responded to the COVID shock to the economy and even into the IC industry. All right, just in conclusion, in the past decade, semiconductor and MEMS manufacturing in China has transitioned into high volume capability. There's many 300 millimeter semiconductor fabs, as well as several 200 millimeter MEMS fabs in the country. There's been a large government push to manufacture both MEMS and CMOS wafers locally. Billions of dollars have been poured into this. The main gap for semiconductors is the sub 14 nanometer EUV lithography. That's the last missing piece. There really are no missing technology or supply chain gaps there for the MEMS industry. Thank you.